Hey everybody, how's it going? My name is Chris and this is my shop partner Oots, and this is my new shop, and in this video I'm going to be installing this radiant floor, and I wanted to take you along for that journey. Now, full disclosure, I am not an expert. This is the first time I've ever done this. I've read as much as I can, watched a bunch of videos. I really focused on publications that were put out by manufacturers and professionals to do this. So I tried to do it the absolute best way I could, and I think I did a pretty good job so far, and I wanted to make this video to show you what I'm doing, how I'm doing it, and pass some of that information on to you. So let's get started, and we're going to backtrack to the bare dirt floor and get to work. So let's go. Oh boy, oh boy. I'm going to have my radiant tubes encased in a 4-inch thick concrete slab. It's recommended in my area to use 2-inch rigid foam down under the slab and also along the entire perimeter. So I'm burying 12-inch strips around the entire perimeter so that they will be flush with the top of the slab once it's poured. The foam acts as an insulation so that the heat isn't being wasted and lost into the ground but remains in the shop where I want it. I also had my plumbers and electricians come out and run all the applicable piping and wiring in the dirt before I put the foam down. After the concrete company came out and made sure everything was graded properly, I could then come back and lay down my 10 mil plastic vapor barrier and then put my 2-inch foam boards on top of that. Once all my foam was down, I added sheets of 6-inch grid wire concrete mesh. The wire mesh will help strengthen the concrete and keep it from cracking. Alright, so I have the foam done and the wire mesh down, and I put the manifold temporarily here in what will be the utility closet, and about the heights that I want it to be, and it's time to start running the PEX tubing. Now, there's companies out there that will make nice maps for you to really help you with those runs, but I'm basically just gonna more or less wing it. I'll start here at the manifold, run out, start doing some loops, and when I get close to running out, I have 300-foot rolls, and so once I know I'm getting close to the end of that roll, I'll make sure I make my way back to that manifold, and then I'll just continue on where I left off on the next one, and hopefully I can do a pretty good job of covering everything equally, and it's not too big of a mess, but that's what we're gonna try, and hopefully it goes well. Another nice thing about the wire mesh is that it creates a giant grid that I could use to lay out and run my tubing. I'm using 12-inch spacing, and so I could just zip tie the tubing on every other row of wire and get really nice runs. I added zip ties about every 2 to 3 feet to prevent the tubing from floating up into the top of the concrete before it has a chance to cure. And they also make these giant plastic staples that are specific for attaching PEX tubing into rigid foam, and I did add those in lots of places as well, and they will hold down both the wire and the mesh to the foam and keep it really nice and tight down there. I have this Combi manifold. It's a brand, and doing a lot of research, this seems like a really nice one, and super well made. It's got some cool features that allow me to adjust flow later on. So, you know, if you have runs that are different lengths, it's going to affect how fast they're cycling each one. So you can, if I have one length that's like 300 feet and another one that's 200 feet, you can slow down the cycle of that 200-foot one so that all the pipe work and all the heating is even. So it's really nice. This Combi model has that, and I can link that model down in the description. I'm adding these conduit elbows, so I'm going to attach these, cut these to length, add my fittings from Combi that attach your PEX to this manifold. I'll put links to all the products and materials I use to do this radiant floor down in the description, and if you're interested in seeing more on this dream shop build and other projects, feel free to subscribe. There's going to be all sorts of cool content surrounding this new dream workshop. All right, we're at 100 PSI. We'll come back in an hour and see if we've lost any pressure. I actually left the pressure test go overnight and it passed with flying colors. I then lowered it down to 18 PSI while the concrete was getting poured. The lower PSI will let you see if they damage a tube and allow you to go in there and fix it. I had a couple half-inch compression couplers on hand while they were pouring in case we had a problem, but luckily everything held just fine. Now in theory it would have been best to raise the mesh up with a ton of what they call little chairs so that the tubing and the mesh are suspended mid-column in the slab. But after seeing how many guys and how fast they were having to work, I really think raising the mesh would have been a disaster. Guys would have been tripping over it, it would have gotten bent all out of whack, it probably would have wanted to be way proud of the top of the concrete. The wire being at the bottom will still add plenty of strength and it saved a ton of potential headache. Plus all of the professional publications that I read recommended this method, but if you do a thicker slab, then it's usually recommended to try to get the tubing a little bit closer to the surface. System held this pressure, it's still holding this pressure. I think I said it about 18 while they were pouring, so that if they broke a line it would show up, but really happy. It's so nice to have concrete in here now. All right, as you can see, a lot has changed since we put all of our tubing down and the concrete was poured. I didn't film a lot of this stuff because after I had the concrete poured, we did a lot of other projects around here. You know, that was pretty much the summertime, and so there's a lot of other things that happened. And when I finally got back to this and started diving into doing all this plumbing, I found out it was very, very complicated. So it took me a lot of research, a lot of time. It wasn't a very fluid, easy thing to film, so I just did it, and the plan was to show you after the fact what I did, explain what I did. I'm going to explain all the components, how I plumbed it. So if you are going to do this, just know right now it's going to be a lot of research figuring out exactly what you need to do. You're also going to want to read through your manual. I read through my the Navion manual, and actually all the answers and everything's in there. It just takes multiple times reading it, reading other things before it all starts making sense. I read through this thing probably at least 6 times. All the manuals for each component, read through them very thoroughly multiple times. Now this video is gonna really help demystify a lot of this, but this exact component, unless you're doing a 2,000 square foot shop like me with this exact combi boiler and the same pretty much everything, then there's a lot of variables that change, and it's not just an easy swap out, okay? After I had done all this, I found an HVAC guy. He actually was a friend of the previous owner who specializes in not only Navion, he does these Navion systems, but he's done a lot of these radiant floors. So I said, hey, I'll happily pay you to come in and give this a look over, tell me if I did everything right. And he came in, he said, yeah, you did a really good job. I don't see any problems. And that was really awesome. So a lot of peace of mind. I wish I would have found him beforehand because it probably would have been money well spent just having him install that. Anyway, let's get to explaining this system. I'll show you exactly everything you need, and this more or less works for any system out there. You kind of need the same components, but again, it's not going to be a complete apples to apples across every single system. So I started out with this Navion Combi boiler. After some research, and I got some good recommendations from some trustworthy people, that these Navion Combi boilers are really nice. They're super efficient. This is the NCB 150E condensing combi boiler. And what a combi boiler is that it provides, on this side right here, these 2 pipes coming down, that is my in-floor radiant heat side. Then over here, it also provides my domestic hot water. So I have my domestic cold water coming in. There's a heat exchanger inside the unit that will heat up and provide my on-demand domestic hot water, so you don't need a separate hot water tank with this system. It's really, really good reviews from a lot of professional people. I'm really happy I went this way, and then just did this all myself. Okay, so this is the Combi boiler, like I said, and for my 2,000 square foot area here, this 150E, based on different heat load calculations, is going to provide enough BTUs to heat it, no problem. And so far, we've had it up for a couple weeks, and it's been doing awesome. Navion also sells this connection here, which is called the primary loop manifold. Now, that term, when I first came across it, confused me. So a primary loop, and you can see they're connected here. What happens is there's a little pump inside here. That was another thing that was hard for me to figure out, was this unit comes with a pump. I didn't know if that pump was for my domestic hot water, if I needed a separate pump for the domestic hot water, or if this pump inside was for my radiant side, and if I needed one or a pump here, a pump on the return, all that kind of stuff. Took me a long time to figure it out. Now afterwards, it all makes perfect sense, but beforehand, it was really confusing. So the internal pump is for cycling water in what's called this primary loop. Now the primary loop, what it does is, from what I understand, is there's these weird kind of hydronics and physics going on here, that when it sends hot water down this supply line, and some of it will go this way and mix into the supply or the return that's coming back, so that this isn't too cold. It actually makes it easier to heat up that water. It kind of mixes. And so that constantly will kind of cycle. Then you need a pump for your secondary loop. The secondary loop is what is providing heat to all my tubes in the radiant floor. You know, you can have multiple zones. Now this is just a single zone. That means I only have one thermostat that's controlling the heat in the whole area. Now if you're doing this in a barn where you might have two separate areas, or a house where you have multiple zones, then it gets a little bit more complicated. You have to have a pump that is talked to from the relay and the thermostats in those areas. I'm not getting into that at all. This is for a single zone system. So you have your primary loop here, off my primary loop, and another thing is I had to use about 4 different fitting systems. I sweated some areas, so this primary loop that was from Navion, and these distances and everything about this is very specific and important. That's why I can't remember, it was like $200 to $400 or $500 for this primary loop. It was kind of expensive for just being some copper pipes. This is important, these distances. Now professional plumbers and installers, they'll usually make this based on all the distances that everything needs to be. I bought the thing, peace of mind, easily hooked up. Has a couple fill and purge valves here, has some valves here, and then it gets into that T. Then I needed to sweat a fitting, and to make it easier on myself, I used shark bite or compression fittings in certain areas, and then I used my PEX fittings in certain areas. Then there's some threaded fittings, all sorts of fittings. It was kind of a mess, but I haven't done a lot of copper sweating. I don't trust myself very well. Luckily, everything that I did is watertight and good. And I know a lot of professional plumbers don't like these compression fittings, even though they're rated, they're accepted by code, and I don't have any leaks in any of them. The thing I like about them is that they're really easy to replace if they do eventually go bad. I don't got to cut copper and then do all the sweating stuff. And it kind of makes it a little flexible too. When I was mounting this stuff up, there's a little bit of flex in it rather than being all sweated together. So I kind of like them, and none of them have failed on me. There's no leaking anywhere, so that's good. Anyway, back to this. We're gonna walk completely through everything. We come out of the primary loop, and I put a pressure and temperature gauge here. This was a little connection I had to sweat in. And then the first major important component that is supposed to happen outside of your primary loop is your air separator up here and an expansion tank down here. Now I think this is a 1.5 gallon, and for my approximately 2,000 linear feet of PEX that's out there, this is an adequate size. And I'm using 1/2-inch PEX for my end floor. My size shop and what I was doing, it's right on the cusp of 1/2 inch, or 3/4 inch. I went with 1/2 inch, and I think I'm gonna be just fine. Then we come along here and we come down to the second component is the pump for the secondary loop here for my in-floor heat. And this is a taco, I think they call it. It's spelled taco, but it's taco or taco. The 007, and it's the high efficiency circulator pump. That's connected via some sweat fittings to these two valve. I don't know their exact name. They're kind of a purge. You also have fill and purge, so you can hook your hoses up and get water in there. And then they also have shut-off valves on it. And then there's a coupling here that's special for this pump. So anyway, this pump is supposed to be after your expansion tank and air separator. Then the pump pumps water into your manifold. Then all your heat goes into the floor and it comes back into this return side. The return side comes over here, and I have a Y filter. I can't remember the exact name, Y separator. So here is my second pressure temperature gauge. That way I can see, is the pressure staying consistent, and is the temperature, what's the temperature returning as? How much heat am I losing? And then it comes back here where it can mix with hot, and this is where that kind of mixing happens, and it goes back into the combi boiler to be reheated and sent back through again. I haven't put the cleaner in. There's a cleaner. I've been letting this run. I'm going to put some cleaner in it, let that run some more, and then I'm going to put some glycol, which is an antifreeze, in there. You have to kind of figure that calculation out as well. Now, another thing is my gas coming in. One of the mistakes I made that was pointed out to me on Instagram, I did a post, is I had used galvanized on my propane line here. There's a kit that comes with the Navion that lets you convert it from natural gas to propane. It was pretty easy, so I did that. There's some little switches in there, and you have to switch one of them from natural gas to propane, so it tells the Navion that you're using propane. And so yeah, I just basically, I had a mechanical crew come in, and they plumbed in all the way over to here. I add this drop down dirt catch, that's what they call it, and then this flexible tube up to the unit. And again, I used black pipe for that. Now over here, cold water, my water coming in, and then it splits right here into a little 1/2 inch pipe that has a backflow preventer. Some people commented that I needed some backflow preventers somewhere else on here, but according to all my manuals and everything, I didn't need one. None of those called for it. They did call for it right here on my water makeup. So if for whatever reason the combi boiler loses water, it actually will make up water for you. So if you lose pressure, if it loses pressure, it doesn't have water, this is what this feed is it's coming in, and it will feed the radiant side water to give it the proper pressure and water it needs. Next to it is your main cold water that comes in, and I have a valve here to turn it off to it. Then there's also this fill purge valve here, so I can turn it off. I can hook my hoses up. Essentially, when I purge the system of air, hooked my hoses up there, one in, one out, flushed it. I hooked it to my little sink right there so I could flush water into it and get all the air out of it before you start it up. And then over here on my domestic hot water coming out of the system, I have again one of these purge fill valves, and this one has a pressure relief valve on it. So the domestic hot water side has 150 psi pressure relief valve. The radiant side up there at the top is a 30 psi pressure relief valve, and that's per the manual. One thing I have to fix is these are supposed to go down, these pressure relief tubes are supposed to go down to about 6 inches from the floor, so I still need to add my extension down there to the bottom. Same with right here. Then my hot water just simply comes out and goes out into the house. Anytime I turn a hot water tap on, the system will sense water's getting pulled through that side, instantly kick on and fire this thing up and start heating that water. All right, over here on the electronic part of things, this up here is it's called the switching relay. it does a couple things. It talks to the thermostat, or the thermostat talks to it. So I have the thermostat mounted on a post out there in the middle of the shop, and I set that temperature to whatever, and when the temperature drops below whatever that is set at, it will send a signal to this, and this thing will fire this pump and start circulating the hot water, and it'll also tell the combi boiler that, hey, you need to start heating up the water. So you have a little communication cable that essentially runs as a low voltage cable. It runs in here, and it will tell the combi boiler it's time to kick on. It also provides power to the pump. Basically, the pump is just turn on or turn off. When this gets told it needs heat, it just turns the pump on, the pump starts running, then it turns this on, and that's essentially how this system works. So one last thing, this is called a condensing boiler. So that means while it's heating, it forms lots of condensation, and that condensation is acidic. And these condensing boilers are apparently super efficient, so much so that you don't even need metal flues or exhaust. You can use regular Schedule 40 PVC. And the exhaust is such a low temperature coming out of it that you don't even need, a regular like chimney flue or anything like that. So I have it exhausted and air intake out the ceiling. So it comes down here. Originally I used the vinyl tubing that came with the Navion. This is also I bought the Navion. This is called a condensation neutralizer. Like I said, the condensation is acidic for whatever reason, but they recommend that you neutralize it. I don't know if it would burn through my tub or cause problems. I use the vinyl tube. Some professional people that follow me said, hey, that's gonna eventually kink, and when it kinks, it'll backflow into here, cause the thing to kick off, and everything will freeze if it's really cold in the wintertime. So use PVC. So I switched it over to PVC, ran it over here, and I have this Y here. So in case there's ever a clog in the main part, if it fills up or clogs, then there's this overflow bypass essentially. So if it clogs, it gets back to here, the water gets past that Y elbow, it'll raise over there and it'll still drain and I'll still have heat. And then I'll just check on that periodically, make sure it's not clogged. And that, I believe, is it.